everyone. In this video, we're going to simplify exponential expression using the quotient rule for exponents. Please remember that the quotient rule states that if we have b raised to the power m divided by b raised to the power k, to simplify this, we can actually take their common base b and we subtract their exponents. So that's how we got m minus k. Please remember that this works only if both bases are the same. Moreover, in this video, we will only consider positive exponents. Negative exponents will be taken in a different video. Now let's take this first example right here. So we're supposed to simplify x to the power 8 divided by x to the power 3. There are two ways to do this, and I'm going to show these two methods of simplifying this expression that we have right here. So for the method 1, or the first method, the first step is to write out or expand each of the terms. So in this case right here, this x to the power 8 means that there are 8 x's. So I'm just going to go ahead and write it out. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that represents the x to the 8th power. We're supposed to divide this by x to the third. That means there are 3 x's. Now, the second step is to divide the coefficient. So in this case right here, the coefficient for both of these terms is invisible 1. So there's invisible 1 if there's no number. So 1 divided by 1 is just 1, so that we don't have to write anything if it's 1. So we just keep it as invisible 1. And then the third step is to cross out or cancel out like variables. So in this case right here, we're going to cross out these x's. We're going to pair them up. We're going to pair these up. So the leftover on top would be 1, 2, 3, 4, 5. There are 5 x's. So we can actually write that as x to the 5th power. Now others are going to say that the leftover for the bottom is 0 because everything is crossed out. That is not correct, because again, if everything is crossed out, remember there was an invisible 1 before these x's. That means that this is actually over invisible 1 or over 1. But then we don't have to write this 1. We can just go ahead and have the 1 invisible. So this means that our final answer for this is x to the 5th power. So this is the simplified version of this expression that we have up there. Now let's have the second method. So I'm just gonna write it out here. Okay, the first step is to divide the coefficient. Again, the coefficient is 1 and 1. So 1 divided by 1 is just 1 and it becomes invisible. Now the second step is to copy the common bases and subtract the exponent of the common base. So the common base that we have here is x. So I can go ahead and write x. And remember, we're going to subtract their exponent. So that would be 8 minus 3. So once we simplify this, 8 minus 3 is 5. So then we can go ahead and say that that is actually x to the 5th power. Again, remember there was an invisible 1 in front of this and I didn't have to write that 1 in the final answer. So this is the simplified version of this expression that we have up there. Now notice that these two are actually the same, which means that you can use any method. It doesn't matter because the answer would still be the same. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're gonna have method 1 here and method 2 on the other side. So I'm just going to go ahead and label the methods here. The first method states that we're supposed to write out or expand each of the terms. So that's 15x to the 7th. So I can go ahead and write 15 and then write 7 x's. So that would be 1, 2, 3, 4, 5, 6, 7. And then I am going to have the denominator as 3. And then this represents 5 x's. So 1, 2, 3, 4, 5. Now the second step is to divide the coefficient. So I'm going to divide these two together. 15 divided by 3 is 5. So I can go ahead and write 5. And then the next step is to cross out or cancel out like variables. So these x's are going to get paired up. So these x's gets paired up and they're going to be canceled out. So that means the leftover here is 2x's. So I can go ahead and write this as x to the second power. Now others are going to say, what happened to the 3? Are we going to write 3 there? Or please remember, we already divided it. 15 divided by 3 is 5. So that means nothing is left at the bottom, but others are going to think that it is 0. That is not the correct answer. So the leftover at the bottom is actually 1. So if nothing is left over, remember, there is always that invisible 1 in there. So then we can go ahead and simplify this as just 5x squared. So this is the simplified version of this exponential expression that we have up there. Now let's have the second method. So I'm just going to go ahead and write it out. Okay, the first step is to divide the coefficient. So this coefficient shall be divided. So 15 divided by 3 is 5. So I can go ahead and write 5. And then the second step is to copy the common bases and subtract the exponents of the common base. So the common base that we have here is x. So I can copy x and we are going to subtract their exponents. So that would be 7 minus 5, so that we can go ahead and rewrite this as 5. X 7 minus 5 is 2, so I can keep that as 5x squared. So this is again the simplified version of this expression using method 2. As you can see, both methods give the same answer. Now let's move on to the next example right here. Again, we are going to simplify this expression using 2 methods. So I'm just going to go ahead and label the methods right here. So the first step for the first method is to write out or expand each term. So this means that we are going to write 4. And then we have 6 x's. So that's what the x to the 6th power means. So 1, 2, 3, 4, 5, 6. And then there are 7 y's. 1, 2, 3, 4, 5, 6, 7. And then this is over. That's going to be 12. So I write 12. And then there are 2 x's, x and x. And then there are 5 y's. 1, 2, 3, 4, and 5. So that we can go ahead and move on to the second step. The second step is to divide the coefficients. So we're going to divide these two. We can actually simplify this. We remember that there's 1 4 in 4, and then there's 3 4 in 12. So that's how we simplify it. And then the x's here are going to get paired up. And so these y's as well are going to get paired up. Please remember that same variables should be paired up. That means you cannot pair up the x and the y because they are not like variables. So as you can see here, the leftover on top is 1. So we get a 1. And then we have 1, 2, 3, 4 x's. And then we also have 2 y's. So I'm just going to have write y to the second power over. The leftover at the bottom is 3. And then all the rest of the variables are gone. So we can go ahead and just write 3 there at the bottom. So we can have this 1 to become invisible. So the final answer here would be x to the 4th, y to the second power over 3. So this is the simplified version of this exponential expression that we have right there using the first method. Let's move on to the second method. So I'm just going to go ahead and rewrite this. Okay, the first step is to divide the coefficient. So we can go ahead and simplify this. There's 1 4 in 4, and there's 3 4 in 12. So as you can see here, the leftover would be 1 on top. So I go ahead and write 1 there. So that's 1 1 on top. And then the next step is to copy the common bases and subtract the exponents of the common base. So the first common base are these two x's. So I can go ahead and write x, and then we subtract their exponents. So that would be 6 minus 2. So I'm just going to show the work here, 6 minus 2. And we also have another variable, which is y. That's the common base. And again, we subtract their exponents. So that would be 7 minus 5. And this is over 3 at the bottom because we have 3 left over at the bottom. So that we can go ahead and say that the final answer for this would be x raised to the power 4, because you have 6 minus 2 is 4. Y to the power 2, because you have 7 minus 5 is 2. And that is over 3. And this is, again, the simplified version of this expression that we have up there. Notice that these two give the same answer, which means that it doesn't matter which method you use, you still get the same answer. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!